All right, yo. I'm back on leetcode. Yeah, let's get it. Okay, given a zero-based permutation nums, build an array answer of the same length where answer of I is equals nums of I for each I from 0 to nums length. Okay, and return it. A zero-based permutation is an array of distinct integer from 0 to this. Okay, we are given nums 0 to 1, 5, 3, 4. Oh, what? Isn't this just way too easy? Like, what? I don't even need to specify this. I can simply do isn't this just the thing? I mean, okay, can you solve it without using extra space, order of 1 memory? Okay, now this is challenging. Let's get this. If I want to do this without using an extra space, okay, so this is 0, 1, 2, 3, 4, 5. Okay, so I need to replace 0 by nums of 0, which is 0. I need to replace this by nums of 2, which is 1. So this should be 1. Hmm. Okay. So when I replace now nums of 1 is 1, but it was 2 earlier. Okay. Then that's impossible to get, right? So instead of replacing this, I see that nums of 2 has nums as 1 in it. Okay, how do we do without using extra space? Okay, this is just a self loop. Now 2 and 1, they are in this, and 5, 3 or 4 are connected like this. Right. I am not sure actually, and I don't want to waste more time here. Let's see how can be done. The intuition behind doing the problem in constant space is that we must process the original array in place in a way that allows us to move the correct value to its correct place I, while also keeping the original value in some way so that we can use it when needed later. we must keep nums I intact, because if for example a later position in the array j. To accomplish this task, we are going to use the fact that if we have a number of the form a q b plus r, where b and r are not multiples of q and r, and this is some math shit, man. Hmm. After this, nums 0 will be 5 plus 6 times nums of I mod n. Nums of I mod n will always be just nums of I, right? So he's saying add let me try this. Nums of I 0 plus n is 6 here. 6 plus 0 plus 6 times nums of I. Nums of 0 is 0, so 0 mod 6 is 0, so this remains 0. Now here nums of 1 plus 6 times nums of I, which is nums of 2, which is 1 mod 6, which is 1 6 7. So here we will store 7. Okay, for here nums of I, which is 1, okay, have I messed up already? I think let's calculate this again. So this is 2 plus 6 times nums of 2, which is 1 mod 6, which is just 1. It should be 8. Let's calculate this. So this is nums of I, which is 1 plus 6 times nums of I. So nums of 1 is 8. 8 mod 6 is 2. Oh sorry, 8. Yeah, 8 mod 6 is 2. So 12 plus 1, 13. Okay, this plus 6 times the number. Okay. Okay, so when we do division, we get the nums of I. If we do mod, we get nums of I. Interesting. Okay, interesting question. Very interesting question. Okay. Okay, let's get back to our usual program, which was 2D dynamic programming. Let's do this regular expression matching. Given an input string S and a pattern P, implement regular expression matching with support for dot and asterisk, where dot matches any single character and asterisk matches 0 or more of the preceding element. The matching should cover the entire input string, not partial. Okay. Let's understand with this. I need to match P and Q basically, right? S and P, okay. So this is S. So we have this A, we have A and asterisk. So when I'm matching these two characters, these two match, then I move both pointers. This moves here. This moves here. I encounter asterisk, right? So I check the preceding element A, which matches, then it is fine. Preceding character. And if it is a dot, then it is fine, right? Contains only lowercase English. P contains only lowercase English with dot and asterisk. It is guaranteed for each appearance of the asterisk there will be a previous valid character to match. I think simple matching is fine. I mean, A matches with A, then we move both pointers. The only thing we need to take care of is this asterisk, because dot is also pretty straightforward. We just skip one character and move on. Okay. Now the point is, let's say this is the string, right? We match the preceding characters. I mean, we can even can there be parentheses and stuff or no? No. So if current is asterisk and previous character matches the this ongoing character, then we simply move this and we don't move this. Whenever it mismatches, then we move that. Okay, let's try. Now int I and int j, if both have reached the end, if I has reached the end, P is the regular expression, right? But if j has reached the length, then return false simply. Now we need to check if p of I is an asterisk. Is a dot. When p of I is an asterisk, I need to check the previous character, which is, oh, what the fuck am I doing? P of j. When p of j is an asterisk, I need to check pj minus 1 with s of I. If s of I is equals p of j minus 1, then return solve as pi plus 1 j. I can even do a while loop here because that will save many things. I mean, I should simply return, right? Why am I doing an OR here? It is pretty straightforward, right? Oh, dot star. Yeah. Zero or more of any character dot. Okay. I can check here if p of j minus 1 is a dot, then return true. Now what should I cache here? What's the point of caching? Okay, this is wrong. Expected true. How is this true? C star A star B. What? Oh. Okay, P is C star A star B. Now I'm matching A and C, they don't match. Oh, C. Okay. Okay, now this is interesting, guys. Because C can come 0 or many times, okay, but there are 0 times. Okay, C star. Okay, okay, okay. If S of I is not equals P of J and P of J, J plus 1 and P of J plus 1 is an asterisk. Okay. Okay, I'm tempted to look at the solution now. Let's see, man. Fuck it. get key I and j is just ij. Bool match if I is less than s dot I and s of I is equals p of j, or p of j is a dot, then match. If j plus 1 is less than p dot size and p of j plus 1 is an asterisk, then DFS SPI j plus 2. Oh, we can either use the asterisk or don't use. Match and this. Okay, this is clever. Very clever. Any tabulation solutions here? Any tabulation? Oh fuck. Should I watch leetcode? Let's see, man, fuck it. But he would be doing the same thing that I did here, right? So yeah, we can just understand this. So what we are doing here is, forget the caching. We are first matching the individual characters. So if I is in bounds, why am I checking this? And s of I is equals p of j, or p of j is a dot, which means we can skip this. Then it returns true or false. Let's say this is true. Now if j plus 1 is in bounds and p of j plus 1 is an asterisk, then what do we do? S p I remains the same, j plus 2, don't use the asterisk. Then match and DFS I plus 1 j. I moves but j doesn't move, because j should be at the dot or the same characters, because it is an asterisk. Return cache key. Makes sense, makes a lot of sense. If there is a match, then we store. If it is matching, then DFS S P I plus 1 j plus 1, we move both, and then we return that. Otherwise we say it is false, return false. Okay, so let's first try it without memoization. If I becomes goes to the limit and j also reaches the end, then return true, right? If j reaches the end, returns simply false. These are the base cases. Now what do we need to do? We need to match the characters. Matching the characters, I mean, is I is less than s dot length, and either s of I is equals p of j, or p of j is a dot, which means we can skip this character. Right. Now we check if j plus 1 is less than p dot length and p of j plus 1 is an asterisk. Then what do? We say return solve sp if we are using the asterisk, which means j should remain the same but I should be moving further. Or if we don't use the asterisk, Then I remains the same and j increases by 2 because we are at the dots are situation, right? Otherwise, if match return solve as p I plus 1 j plus 1 return false. Okay, something leaking. Yeah, j plus 2 can be, no, j plus 2 will never be out of bounds, I'm pretty sure. Why is it going out of bounds? What the fuck? I is moving. What? Okay, why is this false, brother? Okay, it matches. Now j plus 1 is less than this, and p of j plus 1 is an asterisk. Correct. Then we solve I plus 1j. Means we are using the thing. Bro, I already did my Duolingo. Why is it screaming? Like, what's the point, bro? I don't care. Like, if someone crossed my scoreboard, I just. Okay. Oh. Okay, if I'm not using the asterisk. No. Okay, let's create this cache. Okay, this works. Just in case, I will watch the neat code video to understand more. Like, I just want to see the decision tree that he's making here. Okay, this DFS is working, but why not mine? Am I doing something wrong here? If I remove the cache, it should be working, right? Okay, now what the fuck did I change? Return match and this, or maybe I didn't put the brackets here. I can check this submission, right? Oh, this is entirely wrong. No worries. Okay, it works, it works. Makes sense, makes sense. Okay, I will come back to this problem once again. That is why I am not ticking it. So, okay. Let's get on to greedy, guys. Maximum sub array. Is this just cadence? Yeah, it's just cadence. Now, okay, nums of I can be negative as well, so try coding another solution using divide and conquer approach, which is more subtle. We start from mid -1, we go till L. Hmm. Pretty interesting. But I mean, if I solve it using cadence, why are they asking divide and conquer? Like, do they have something in their ass? If I have given it perfect solution of order of n, why do they ask another approach? Is it just fucking... Pradeep Pal is here. Hello, brother. How are you? Divide and conquer approach. I mean, I don't know if it is important to know. I don't know, man. But yeah, we can write it just to be the cool. Less time. No, there's no way that divide and conquer has less time complexity. We can test this out right now. So I have this cadence, right? I'll submit this and we'll check the time. So it beats 20.55%. This is order of n. This is cadence. Let's see with divide and conquer. First, we'll understand how this works, divide and conquer. So the approach that I studied here is the maximum subarray sum can either be in the left part of this array or in the right part of this array, or something in between which includes this middle element. So if this is L and this is R and this is M, so the maximum subarray will be some sort of recursion along with basically function from L to M minus 1, or entirely in the right subarray, which is M plus 1 and R, or L dash to M minus 1 sum. This is the max sum plus M minus 1. This should be minus. Plus nums of M plus right sum M plus 1 R dash. This kind of thing. Let's write the DFS thing, recursive function here, and we'll check the time complexity. So the function will be int function. We pass in this nums. Yeah, basically like merging. It feels like kind of a binary. I mean, we are dividing the array in half every time, so kind of a binary search thing, but it's not exactly binary search. It is divide and conquer. Let's see. So we have the left, let's call it smaller case, lowercase l and lowercase r. Return function nums 0 to nums dot size minus 1. Now if L is greater than R, then we should return something which should be minimum, basically int min, right? Because there can be negative numbers, so we can't return 0, because if an array contains only negative numbers, then the maximum sum will be negative. Okay, now what do we want to see here? We want to calculate the middle point, which will be just L plus R by 2. Now we need to calculate 3 things, as you see here. So this is straightforward, we just do the recursive calls, but we need to manually calculate these two, mainly this sum and this sum, which is just the maximum sum in the left part and maximum sum in the right part of M. So let's call it left max equals 0, right max equals 0, for int I equals M minus 1, I is greater than equal 0, I minus minus, current plus equals nums of I, and left max equals max of left max and current. Right, let's reset current again, and we calculate the right part. I is less than R equals I plus plus current plus equals nums of I, and right max equals max of right max and current. Now we need to do the recursive calls here. We simply first of all do L M minus 1, then we do M plus 1 R, Then we do function of left max plus nums of m plus right max. We need to return maximum of these three, so we just do max, we do this operator, boom boom boom, comma comma. Any base cases that we need to take care of apart from this? I don't think so. Let's see if this works. Okay, time to see if it beats cadence. I don't think, I have zero belief that this will beat cadence. Yeah, it time limit exceeded, so it's not even accepting this solution. Why is it time limit exceeded? Why is it time limit exceeded, brother? Oh, this should be L. Enter. Yeah, it doesn't, right? So interviewers just want to fuck with you and ask this problem in divide and conquer because cadence is better. I don't know why. Okay, fuck it. Let's get to jump game. You are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or false otherwise. This seems like a recursive thing. So from 2, I can represents your maximum. So I can jump 1 step or 2 step. If I jump 1 step from index 0 to 1, then 3 steps to the last index. Return true if you can reach the last index. How? Just reaching. Oh, it can be 0. Okay. Isn't this a recursive thing? I mean, let's see. If I'm at I can move to I plus nums of I positions, right? This is my range. So I can simply do for int j equals starting from I plus 1. J should be less than or equals I plus nums of I, j plus plus. My last base case would be I is greater than equals nums of I, nums dot size, then return true if solve nums j, return true, return false. Now, should I add a cache here? I should, because yeah, I should add a cache here simply to say that at ith position, from ith position I can reach the end, right? Let's add that. So vector int cache nums dot size plus 1 minus 1. If cache of I is not equals -1, return cache of I. Otherwise, just assign cache of I is equals true, and we also consider the false case. What happened here? Okay, cache is undefined. We should do this, or I can simply do this and just get this guy right here as resize. Okay. Oh, what? Oh. Zero. Expected true. Now, I is 0, which is... Oh, what? Oh. Just the last index. We don't need to exceed, brother. We don't need to exceed nums. If we are at the last index, it means it is true. That was a dumb. But this is pretty slow. Why is it slow? Because we are doing a bunch of recursions that we don't need to do. Instead of doing this, what can be done here? Since this is part of greedy, so let's think of a greedy solution. So from 2, I can simply put these 2 as true. So this will be an n square solution, right? Is it an n square solution? Yeah. Or should I take the most steps? But that doesn't mean, I mean, there can be a 0, which is just crazy, right? Okay, let's see. If I create a vector bool, what? Bool can visit. Then can visit of 0 is true. Return can visit of n minus 1 for int I equals 0. I is less than n and cache of I plus plus for int j equals I plus 1, j is less than equals I plus nums of I, then can visit of j equals true. What? Oh, I mean can visit of I. Can visit. I plus nums of I. What? J, for in j equals I plus 1, j is less than j plus plus. Okay, this should be faster. This is just n square in the okay. What happened? What happened? What happened? And j is less than n. Na 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 na. Na 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 na. Let's see. Still pretty bad. Let's look at my previous solution. Okay. I equals 0, reach equals 0, I is less than n, and I is less than equals reach. What? I plus plus, reach equals max reach, I plus nums of I. Oh, yeah, this is a fair solution. We are maximizing reach here, like we keep track of how far we can jump. That's a good point, man. I didn't think of that, but that's why we are practicing. That's the point, man. Okay, int n equals nums dot size, which I don't need exactly, but still, for int reach equals 0, I is less than n, and I is less than equals reach, plus reach equals max of reach, and I plus reach should be right. Oh, even like we are maximizing reach. We are just checking how far we can jump, and we just do that in order of 1, man. That's crazy. Okay, I need to get out of that DP recursive mentality to feel these greedy solutions, man. Otherwise, it'll be just a bunch of rework. Hopefully the music is banging. Yeah, it's fine. Okay. You are given a 0 index array of integers nums of length, and you are initially positioned at nums of 0. Each element nums of I represents the maximum length of a forward jump from index I. In other words, if you're at nums of I, you can jump to any nums of I plus j, where 0, j, nums of I, 1, I plus j is less than n. Return the number of jumps, a minimum number of jumps to reach nums n minus 1. The test cases are generated such that you can reach nums n minus 1. Okay, minimum number of jumps. Okay. La 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 la. I make a hop here, and a hop here. Okay. Isn't this a 2D DP? Is this just 2 DDP? Huh? Right? Yeah. Let's say we have this, right? Okay. We start from here. We have a DP array. I'm still going in that DP direction, bitch. Why the fuck? Minimize the number of jumps, man. So at max, the maximum number of jumps can be when each of them is just one, it'll be n. But from 4. I mean, yeah, a fair solution that I can think of is I'm at 0 jumps here. Then I go to the range of this guy, so 1 jump here, 1 jump here. Then I go to the range of this guy. This remains 1, this will go 2, and this will also go 2. So I return simply 2 here, maybe. Yeah, brother. But I also need to keep track if I can even visit that thing. But it is guaranteed that you can reach. Okay, let's see. What have I done here? Okay, if n is 1, return 0. Int minimum steps is 1. Int steps equals num 0. Max range is num 0. Yeah. In I equals 1, I is less than n minus 1. Max range equals, we update the max range. Okay. Now this is tricky, man. That's why I hate greedy. See how many times I have, 11 times I have attempted this question and I have failed half of those. Steps minus minus. If steps become 0, steps equals max range minus I. Max range minus I, yeah. Minimum steps plus equals 1, because we are starting a new jump here. Yeah, makes sense, fair. Pretty fair solution, yeah. Let's ask ChatGPT, man, how to do greedy problems. How to do greedy programming problems. Greedy algorithms make the optimal choice at each step with the hope that this leads to a global optimum. Here's to how to approach them. Read the problem carefully. Identify what you are optimizing, minimizing cost, maximizing profit. Look for constraints and edge cases. Check if a greedy approach is applicable. Greedy works when local optimal choices lead to a global optimum. Common indicators: you are asked to maximize, minimize something. Choices don't affect each other much. No overlapping subproblems. The problem is similar to a classic greedy: activity selection, Huffman coding, interval scheduling. Decide what your greedy choice is. Prove that making this choice at each step leads to the optimal solution. If unsure, try counter examples to test the greedy choice. Sort or prioritize based on greedy criteria. Sorting is often necessary. by start time, end time, cost per unit. Use a priority queue or custom comparator if needed. Implement the algorithm, loop through sorted elements, make the greedy choice. Okay. But this is pretty fucking bizarre, man. Fuck it. Okay. We are keeping track of how many steps we are allowed to take, and we are also keeping track of how far we can go. If we run out of steps, we replenish them by doing a max range minus I, right? And then we increase the jump count. Yeah, okay. Int steps equals nums of 0. How many steps can you take? Singular steps. How far can we reach? If steps, okay, max range equals max of max range and I plus nums of I, right? If steps becomes 0, then steps equals max range minus I, jumps plus plus, return jumps. What? Why are we doing n minus 1? Yeah, we don't need to calculate range at n minus 1, we just need to reach there. Yeah, makes sense. Makes a lot of sense, makes a lot of sense. I hate greedy problems. What? What? If n is equals 1, return true. What? Ah, returns 0, brother. Okay, I need to do these again, man. Okay. Gas station. There are n gas stations along a circular route where the amount of gas at the ith station is gas of I. You have a car with an unlimited gas tank and it costs cost of I of gas to travel from the ith station to its next I plus 1th station. You begin the journey with an empty tank at one of the gas stations. Given two integers gas and cost, return the starting gas station's index if you can travel around the circuit once in the clockwise direction. Otherwise, return -1. Return the starting gas stations if you can travel around the circuit once in the clockwise direction. Otherwise, return -1. If there exists a solution, it is guaranteed to be unique. Okay. I hate greedy problems, man. You know what? I need to take a break. I'm too much into DP shit, so I can't think of anything other than recursive and fucking caching and shit. So I need to take a break from greedy, man. I need to come up with a fresh brain to get into this. Meanwhile, we can do some other shit. Maybe. Let's get this to 100 and then we close the stream. Let's do a linked list because why not? You are given the head of a singly linked list. The list can be represented as this. Reorder what? Okay, there is a bug on my fucking desk. It is way too humid out, man. Okay. Back to the question. So what do we need to do, man? You may not modify the values in the list node. Only nodes themselves may be changed. Reorder the list to be of the following form. Okay. If it is 1 2 3 4, it should be 1 4 2 3. Okay. Interesting. Okay, let's see. 1 2 3 4 5. It becomes 1 5 2 4 3. Isn't this just like, I mean, if I take this and then I reverse till half, like I do this and this, then I take this and this, I push it in here, and then I push it in here. Yeah. So I think the solution is I start with a linked list like this. 1 goes to 2, goes to 3, goes to 4, goes to 5. I need to reverse this list, but only the second half. Only the second half, right? So, first of all, I need to find the middle point here, right? So I can do that by using a slow and a fast pointer approach. So both of them start at this and this. Slow moves by 1, fast moves by 2. Slow moves by 1, fast moves by 2. Fast goes to the end. So this is my middle point. Then I simply need to reverse from here, right? Then when I do a reverse from here, it will look something like this. This becomes this, this becomes this. Now I have this head and tail. Then I just need to mix and match these. So after one, I should put a tail node. Right, so after one, I should insert this tail node here. So after one, it should be 5, and then 2, and then tail moves here, right? And head will be at here, right? Then this will be tail. Then I need to push this tail here. So 2, 4, 3, null. And I think this is the desired 1, 5, 2, 4, 3. Okay. Reverse the second half of the linked list. Right. Now middle is the slow thing. Now I need to reverse from middle. One thing I didn't clear up enough is when I did this, what is the next pointer of 3? It can be null. I mean, it's pretty obvious. Yeah, it can be null pointer. It'll be easier to code also. Right, so list node prev equals null pointer, right? Current is just mid. Current is just mid, right? Let's call it current midpoint, and then next node is, we don't need this, while current list node next node equals current next, right? Current next equals previous, previous equals current, current equals next node, right? Now previous will be at the tail. So let's call it tail, and then we can use current again. Current becomes head, while current intertwine from head and tail. Basically head, tail, head, tail, and so on. Now current is at head. Okay, what should be the things here to do? This is head, tail. I need to keep track of this. This will be next, right? Then current next is tail. Head next and tail next. Yeah, I need to keep track of these two. Current next will be tail. Tail next will be head next. Tail becomes tail next, head becomes head next. That's all. So list node head next equals current next. List node tail next equals tail next. Right. Then current next equals tail. Tail next equals head next. Current equals head next. Tail equals tail next. Right. At the end, somewhere we'll be at here. Okay, now there can be cases of even and odd length linked lists. Okay, now let's see. If I'm at here, head next, right. Head becomes at 2, right? Current and current next. Current and current next. At the end, let's return head. Let's see if we cooked or we just farted. Return head. Ah, we don't need to return anything. Oh shit. That's crazy, yo. Okay, one of them passed, but one of them didn't. 1, 2, 3, 4. Let's see this example here. 1, 2, 3, 4. Now there is no middle point exactly, right? Let's see how the fast and slow pointer would work. So slow becomes here, fast becomes here. This is considered as middle point. Then we reverse on the middle. Null. 3 changes the arrow direction to here. 4 changes here. This is the head, this is tail. Now what are we doing here? 1 goes to 4, 4 goes to 2, and 3 goes here, and this is null, but we are at this position, so current next is null, so we can't do anything. But tail is at here. Okay, so yeah, I think in even cases, if current is existing, then we can simply say current next equals tail, tail next equals null pointer. Let's see if this is cooked or just a shit code. Yes, bro, linked list is my bitch. I love this bitch, man. All right. Cool. Let's see. Okay. Remove nth node from end of list. How many have we done? 97. Just 3 more to go, guys. Just 3 more. Given the head of a linked list, remove the nth node from the end of the list and return its head. Nth node from the end of the list. Isn't this pretty easy? So for this, we say this is the current. This is, let's say, T. Right, N is 2, right? Let's say N is 2 here. So we start from T. We just do 2 hops on T, so T becomes here. Then we move both current and T until T reaches null pointer. So current becomes here, T becomes here, current becomes here, T becomes here. Right, and we need to keep track of previous as well. So current becomes here, T becomes null pointer. So the current is the position where we need to delete. This will be previous. We simply say previous next equals current next and delete current. That's all, man. What even is this? Okay. So let's say this node current equals head. This node T equals head. For int I equals 0, I less than n, I plus plus, T equals T next, while T current equals current next, T equals T next. Can there be cases where n is fucking not even not in the range? Like T can reach null pointer here and I'm doing some null pointer exception and shit like that. The number of nodes is SZ. Oh, okay. Okay. Now there can be a case where n is equals to the size of linked list. So previous will be so in this case when n is 6, right? So 1 0 1 2 3 no, n is 5. Okay, 1 2 3 4. Zero, 1 2 3 4. If prev is still null pointer, then return head next. No. What? Yeah, we need to delete current, right? Then prev next equals current next and delete current, return head. Let's see if we have cooked. Yeah, brother. If I don't do this, yeah, bruh. Yeah, bruh. Yeah, I mean, it's all right. Okay, linked list is my bitch, brother. One of my favorite questions. A linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list or null. Construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes where each node has its value set to the value of its corresponding original node. For the next and random pointer of the new node should point to new nodes in the copied list such that the pointers in the original list and copied list represent the same list state. None of the pointers in the new list should point to nodes in the original list. I think there will be a follow up without using a fucking cache or a map, right? So my first simple fucking uh, thing is just copy the list linearly and then keep track of fucking uh, make a map from old nodes to new nodes. Oh, it's just a node. Like, can you be consistent, leetcode, man? Are you fucking dumb? Let's call it ancient modern new node of ancient val, right? Temp equals new node. Oh, I need the fucking map as well, man. Map ancient modern, right? Shit. Well. Let's see if we have cooked again. Yeah, but why is this so slow, bro? What? Yeah, he's doing the same thing. While current is not equals null map current new node current equals current next. Yeah, bro. What? Yeah, pretty much the same. I'm just creating a lot more to make it verbose and fucking readable. It's the same shit, bro. Oh, without using the fucking map. Create a copy of each node and put it next to the original node. Oh man. These brain teasers. Shit, I hate this. Assign the random pointers of the copied nodes. Yeah. Disconnect the copied list from the original list. Shit, bruh. Shit, bruh. Yeah. Do I need to write this, man? Fuck, man. I'm just so. Fuck it. Okay, let's write it. So if we are not allowed to use a map, then we do some fancy shit. Copy each node and put it next to the original node. Right, node star current equals head while current next node equals current next node clone equals new node current val current next equals clone next equals next node current equals next node. Assign the random pointers of the copied nodes. Current equals head again. Clone equals current next. Clone random equals current random next. Right. Okay, so I simply need to do current next equals current next next clone next equals clone next next. Oh, what? Clone next, clone next. Yeah, bro. Next. Mm, 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 mm. Clone next next. What? Yeah, if clone next is null pointer, then we can't do anything, right? Yeah. Mm-hmm. Oh, same shit here. Okay, I messed up, brother. Yeah, just keeping one is fine, man. Okay. Next node equals current next next, right? If current random is not null pointer, then current next random equals current random next. Yep. Easy. Pretty easy. Then disconnect the two linked list. Yeah. Clone head is this. Yeah. While current, then current next equals current next next. Oh, I need to move. I need to move it. Ah, man. Okay. Current equals current next, and clone equals clone next. Right? Cool, cool. Add two numbers. Bro, I'm not doing bit manipulation. Math and geometry. Yeah, we can do that. We'll do it at the fucking end, brother. But this is important. Intervals is important. Pretty much. Pretty good. I haven't touched sliding window, bruh. Trees. Oh, this is the bomb, man. You are given two non-empty linked lists representing two non-negative numbers. The digits are stored in reverse order, and each of the nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Okay, so pretty easy. Pretty easy. So the numbers are 2, 4, 3, and 5, 6, 4. One way would be to fucking create those numbers, but the length is insane, so we can't do that. So another way is reverse them and then keep track of carry and then create a new linked list with the result. Let's do that. Node current. Okay. The sum is R1 val plus R2 val. Answer next equals R1 val plus carry. Oh shit. What? What? Oh no. 2495649, bruh. Shit. Shit. Okay. Makes a lot of sense. Okay. What do I need to do, brother? But I'm doing it right? 249 plus 5649, right? That is the question, right? Yeah, 249 plus 5649. Expected 70401. What? Oh, it's already in reverse. Oh, fuck. Then why? What? Am I a dummy? It's already in reverse, bacha. What? Shit. So it's just L1 and L2. I don't need to reverse them. Bro, I'm so bad. I can't do English, man. That's my problem. That's my fucking problem, man. I just can't read English. Fuck it, okay. Alright, I believe 100 questions are done and it's exactly at 2 hours of the stream. So, that's it for today, guys. I'll be back tomorrow. Most likely the same time, I believe. But yeah, until then, please take care and have a good day or good rest of the night. GG's.